Okay, now on to operations and compositions of functions. Okay, here are two functions, an f of x function and g of x function, and we're just going to do the different operations. Notice that the way that it's written is it can be written together or separate, but it still just says add the function, so it's not so difficult. The thing to remember is that a function is its entire unit. So when you're adding, oops, that doesn't help, does it? So when you're adding, it's x squared plus 1 plus 3x minus 2. There's no distributive or no need to distribute a positive 1, so we just combine our like terms, and this is x squared plus 3x minus 1. So the domain that we're looking at is from the originals, and the originals are negative infinity to infinity for the quadratic and negative infinity to infinity for the line, so there are no restrictions. So this domain is, whoops, I don't know why I did that, sorry about that, is negative infinity to infinity. Now subtraction, it's important to put the parentheses because you're going to distribute that negative 1 to the second function, which is g of x. So don't forget to do that. So this is x squared plus 1 minus 3x plus 2. So x squared minus 3x plus 3. Again, there are no restrictions, and the domain of quadratic is negative infinity to infinity. Okay, I just moved these functions at the top, so I don't have to go look at them. Multiplication. So we're going to do x squared plus 1 times 3x minus 2. And remember, I forgot the square. We are, a lot of you use FOIL, so I'm going to multiply x squared by both of the terms. So I get 3x cubed minus 2x squared. And now multiply the positive 1 plus 3x minus 2. This is already in proper order, so there are no restrictions, and this again is negative infinity to infinity because this is a cubic. Now we have division. Division we have to be careful of. So the f function is on top. The y function, the g function is on the bottom. And this is a rational function. So we have to pay attention to its restrictions because the denominator cannot equal to 0. So 3x minus 2 equals 0. I'm going to add that 2 and divide by that 3. So x cannot equal to 2/3. So my domain is going to be negative infinity to that 2/3. Stopping at 2/3, starting back up on the other side of 2/3 and going to infinity. Okay, now on to compositions. This is where we put one function inside the other. It can be written as, it looks like fog, F-O-G, or it'll be like f of g of x. And goff would be g of f of x. This says put g into f, and this says put f into g. So f of g of x, I am going to write my f function down. And in place of my f function, I am going to replace that x with the g function. So this is 3x squared plus 4. There's no math to do, so this is just 3x squared plus 4. And that would be its final answer here. Okay, this says start with my g function. So I am going to write down my g function. and it says to replace the x with the f function. So I'm going to do 3 and then x plus 4 squared. Now there's some math to do. If you remember from another video, I do square, double square. So square the first, double it. So remember that multiplies to 4x. So plus 8x, and then square the last. Now I'm going to distribute and get 3x squared plus 24x plus 48. And now that one is in order, so it too is done. Okay, this says f of g at -1. So we're going to find g at -1. So g at -1 is 3 times -1 squared. So this equals to 3 times 1, which is 3. Now I'm going to go to the f function and plug in that 3. So f at 3 equals 7. And there's that answer. Now this one says try f at -1. So, I'm sorry, +1. So that's 1 plus 4, which is 5. And now I'm going to take the g function at 5, which is 3 times 5 squared, which is 3 times 25, which is 75. So g at 5 is 75. Okay, I'm going to find g at 2 and subtract f at -2. So g at 2 is 2 squared over 2 minus 1, which is 4 over 1, which is 4. Now I'm going to find f at -2, and that's -2 squared plus 1, which is 4 plus 1, which is 5. And now I'm going to take that g at 2, which is 4, subtract the f at -2, which is 5, and so this equals to -1. This tells me to add the functions together and put in -3, but when I look at this, this looks a little bit more complicated because of the adding something with a common denominator. So I'm going to put -3 into both. So I am going to do f at -3 is -3 squared plus 1, which is 9 plus 1, which is 10. G at -3 is -3 squared over -3 minus 1. So this is 9 over -4, so -9/4. So 10 plus -9/4 is common denominator here would be a 4, so 40 plus -9/4 is 31/4, and that's that answer. Okay, so now we have a division problem, so I am going to have some restrictions. So I go to my original, and this has a restriction where x cannot equal to 1. And then I'll see if I have any more restrictions after I put them together. So it says take the f of x, which is x squared plus 1, and divide it by x squared over x minus 1. Now I've got to get rid of that fraction, so I'm going to multiply the bottom by its reciprocal, which the x squared comes to the bottom and the x minus 1 on top. What I do to the bottom, I have to do to the top. So this bottom goes to 1, and I get x squared plus 1 times x minus 1 over x squared. So now I know x cannot equal 0. And now I'm going to put this together and simplify it more. So x squared times x is x cubed. X squared times -1 is -x squared. 1 times x is x. 1 times -1 is -1. all of this over x squared, and there's that solution. Okay, this next one says to find f of g at -1. So I'm first going to find g at -1, and that's -1 squared over -1 minus 1. So that equals to 1 over -2, so that's -1/2. Let's make sure that we remember that x cannot equal to 1. Now I'm going to find the f function and use the -1/2 in it. So f at -1/2 is equal to -1/2 squared plus 1. And that equals to +1/4 plus 1. So this equals to 5/4. Okay, so looking at these next two functions, neither one, this function has no restrictions because it's a quadratic. So now I'm going to plug in 1 minus √3 into the g of x. So that is 1 minus 2 times 1 minus √3 squared. So 1 minus 2, I can double square this, square, double, square, and so 1 minus 2, 4 minus 2 √3 to combine the terms. Now remember we're distributing a -2. So 1 minus 8 plus 4 √3 is -7 plus 4 √3. And there's my solution. This next one says I'm going to plug in that x plus h into the g function. So that's 1 minus 2 times x plus h squared. We could double square that, square the first, double the multiplication, which is 2xh, and square the last. Now distribute again that -2. So 1 minus 2x squared minus 4xh minus 2h squared. So I'm going to do -2x squared minus 4xh minus 2h squared plus 1. And there is that solution. Okay, so I have restrictions. When I use the g function, g, x cannot equal to 0. So now I go through and do what they say. It says take the f function and plug in the g. So the f function is 3x minus 3. So remember, I'm replacing that x with the g function. So that's 3 times 1 over x minus 3. So this is 3 over x minus 3. And there is that solution. And now this says take the g function and put in the f. Remember right now, x cannot equal to 0. So let's take the g function, which is 1 over x. We're going to replace that x with the g function. So this is 1 over 3x minus 3. So 3x minus 3. Remember, my denominator cannot equal to 0, so I set it equal to 0. So x also cannot equal to 1. And there's that solution. Okay, f of f at 4, which says I'm going to put the f function inside itself and then find it at 4. So the f function is 3x minus 3. So in place of that x, I'm putting itself. So 3 times 3x minus 3 is 9x minus 9 minus 3. is 9x minus 12. Now I'm going to find, oops, is 9 times 4 minus 12. 36 minus 12 is 24. So there is that solution. Now G of G, the first thing we got to remember is that x cannot equal 0 because that's the restriction. So I'm going to take my G function, and in place of x, I'm going to put the G function again. So 1 over x. I'm going to multiply it by its reciprocal, which is x over 1. This goes to 1 at the bottom, x on top. So x is its solution. Now I'm just going to plug in 4, so it is 4. So there's that final answer.